So in my pure virtual functions, if I'm going to declare a pure virtual function over here, so the first rule over here is the pure virtual function should be present in a virtual class. Now, let me revisit again. So I haven't started the recording yet. So that's why I'm revisiting the concepts again. So coming to my virtual class, the virtual class is a class which for which no object cannot be created. Okay, for your virtual classes, no object cannot be created, but you can only extend your class from a virtual class. Okay, for example, if I'm going to declare a virtual class over here, then for this virtual class C1, I cannot create an object. Okay, here I cannot create an object for my virtual class. Okay, so if I'm trying to write down C1 underscore H is equal to new, the compiler will throw me an error. Okay, let me show you what is going to happen if I'm going to create an object for my C1 underscore H. See, I'm going to get an error saying that cannot instantiate abstract class. Okay, abstract class is nothing but my virtual class. I cannot create any instance for my abstract class. So I can only extend my virtual class. So I'm extending C2 from my virtual class C1. Okay, that is nothing but your virtual class. Now there is one more thing which is known as pure virtual function. Now in your pure virtual function, you're going to write down pure virtual, and there are two rules for your pure virtual function. The first rule over here is pure virtual functions cannot have any body declared. And second rule is pure virtual functions should be only declared inside your virtual classes. Okay. So pure virtual function is declared only in your virtual classes, and pure virtual function should not have any body. Let me come into this and let me show you what is going to happen. So if your pure virtual function is going to have a body, then you're going to get this errors. Okay. So pure virtual function should not have any body which is present in it. Okay. And the third rule over here is when you're going to declare your pure virtual function, or whenever you're going to have a pure virtual function, then definitely you need to override that particular pure virtual function in your child class. Let me come into this overriding process and let me show you. See, so class declare C2 cannot as a non-declared abstract class due to missing implementation of pure virtual methods. Okay, so definitely you need to override your pure virtual function which has been declared inside your parent class. Then only the compiler is going to accept, or else it is not going to accept. Okay, so this was about your virtual class and pure virtual functions. Is it clear, guys? Any doubts or any queries? Abstract classes Java. Abstract class. I'm not so much aware of Java. Yeah, so this will also be used in our UVM. So in UVM, we are going to declare just the templates, whatever the functions we are going to have. In your parent classes, there will be so many built-in classes. So in that particular built-in function, built-in classes, this there will be some methods which will be declared as pure virtual functions. And whenever you're going to extend your user-defined class from them, you are going to write down or you're going to override them. Okay. So there in UVM, you can find the more applications of this pure virtual function and virtual classes. Okay. Yeah. No, no, we cannot change anything. Whatever the function definition is present, that particular function should definition should be present. This is what we are going to have in UVM also. So you will be having some methods which will be declared as pure virtual function. So whatever the definition is present, that definition only you need to have in your child class. Okay. Yes. Is it clear? Any doubts or any queries? Can we use only extended method for pure virtual class? Extended method. Sorry, I didn't get it. Uh, Direct method only. I haven't got your question. You mean this? No, 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 no. Definitely, we need to override it. If you are going to declare a pure virtual function, definitely you need to override. That is what I've shown you, right? by commenting. Yeah, yeah. Okay, okay, okay. Yes. Now, so that was about our virtual classes and pure virtual functions. Okay. Now let us see about our parameterized classes. Okay. So as in our Verilog, we are going to have parameterized modules, right? So here in System Verilog also we are going to have parameterized classes. Okay. So let me show you how to declare a parameterized class. I hope everyone knows about parameterized modules. If you are not aware, you can refer to the playlist which we have discussed on Verilog, where we have discussed any in a clear detailed manner about what do you mean by parameterized classes and all, sorry, modules and all. Okay, so we are going to have a simple module, and here I'm going to declare a class with a parameter. Let's say the class name is packet, and I'm going to declare a parameter. Let's say the parameter name is width is equal to 8. Okay, this is my parameter which I'm going to have. Now here internally I'm going to use this particular parameter, this parameter minus 1 down to 0. Okay, which is nothing but data. Okay, now here I'm going to display function void display dollar display. The value of width is percentage d, and data is percentage d, comma width comma data. I'm going to display this too, and followed by end function. Okay, and end class. Now, within an initial beginning block, what I'm going to do is I'm going to instantiate my class packet by having the handle, and before that I'm going to change the parameter value to 16. Okay, and I'm going to declare the handle, and I'm going to write down p1 is equal to new, and let's say p1 dot data is equal to, let's say, some 8 tick h a5. Let's give it as 8 tick h a5, or let's say we have changed it, right? So it's 16 tick h, let's say it is a5 bd. Okay, and let's end it. And before that, what I'm going to do is I'm going to call the display method p1 dot display, and followed by end the module. So what is your parameter? Parameter is something, but you can override the particular values. So parameter is a named value, or it's an alternate name given to your constant value. Okay. So outside of your class, you can basically able to configure that particular value or the parameter value. So instead of giving your hardcode values, for example, if I'm going to give bit 7 down to 0, if I want to change the width of my data, then I need to go into my code, and I need to change it by erasing the value, and I need to alter it. So instead of doing this particular things, we can declare this particular thing as a parameter, so that our code can be configured from outside the class also. Okay, so here you can see the width of the data has been changed to 16, and data is 4249. Okay, so this is where we are going to use this parameter, and this we have discussed a lot in our Verilog also. Okay. Now, so there is something new in our system Verilog. There is something known as typed parameter. So what is this means? Let's say if I'm going to give, let me copy this one and paste it over here. And here I'm going to write down type t is equal to int. Okay, so this now t will be acting as a int data type. Okay, so let me write down t data. Okay, now this data is a variable, and t is a data type. Okay, now what I'm going to write down here, data is percentage p. Let me write it down. Let me change this display function. Data is equal to percentage p comma data. Okay, just have changed this particular thing. Okay, and let me end the function, and let me call it. So what I'm going to do, let me create the handle for that. So how I'm going to create it, packet, and when I'm going, let's see, let us take the int only, as my parameter. Let's say the packet handle name is P1, and let me create one more handle over here. And let's say I'm going to have another data type as string. Okay. So what is that it is going to happen over here? Now this data will be of type T. Okay. So T is nothing but it is of data type int. So this data, whatever the variable we have, right? It is now of type int data type. So data here is of int data type. Okay. Now, if we are going to reconfigure it, or if we are going to configure it, this value to string. So here you can see we are passing the parameter as string. So what happens over here? This t will be of now string, and this data or whatever the variable which is present here, right? That will be acting as a string. Okay. Let me show you how it is acting. Let me create the object for this. P1 is equal to new. P2 is equal to new. And let me call the display functions P1 dot display and P2. And P1 dot data is equal to, let's give it as 10, and P2 dot data is equal to, let's say, VLSI. And let me call the display functions P2 dot display. See, data is equal to 10, data is equal to VLSI. In Verilog, what we have seen using the parameters, we were just changing the constant values. But in SystemVerilog, there is something known as typed parameters. Using this, we are changing the data type of the variable itself. This is a powerful option which we have over here. Here we are changing the data type of this variable. Okay. Initially, it is this data type is int. Now we are changing it to string by configuring or by passing the data type over here. Okay. So this is how your typed parameter is going to work. Is it clear, guys? The difference between normal parameter and typed parameter? In 86 line, can we write like this? No, that is what I'm saying now. Here you need to pass which data type you need to have. Here you need to pass what is the data, which data type you need to pass. Is it clear for everyone? Yes. And what about others? Is it clear? Any doubts or any queries in this?